Hello, hi. This video is about the project at the end of this course. For this one, the project is given is about project power generation and data is given. So the first thing is to identify that what kind of algorithm I'm going to use. So based on the data that there are basically two tasks which we can identify for more to identify the problem, what type of problem we have. So we have the historical data and we want to do the forecasting. So the first thing is identification. Is it regression data, or is the regression problem or the classification problem? So what I've identified is that it's a regression problem. So I will be using a regression algorithm to identify the trends. The second important point is that what are the important features in this data set. So in this data set, I have been given data for temperature output, basically that output power with as a target feature, and then I have ambient temperature and another one. So I believe that the temperature feature is the most important feature because temperature determines the remaining available value. So remaining available features are dependent on the temperature. So when the temperature rises, the power becomes there is more power generation, and when temperature reduces, there is the power generation is reduced. Another thing, so it means that whatever fuel we are using to generate that temperature is also impacting. So if I do the calculation based on the temperature, I can have a better estimation on the power generation and ultimately how much cost if I'm doing the cost calculation of that model for that forecast, that if I want to do the costing based on that my forecast, I can also able to identify based on that. So that's why I think that temperature is the most important feature for this data set feature. So since I've identified, I'm going to use the regression as part of the activity. The most important feature set I believe is the temperature. And the third important thing is that in terms of using the tool, either I'm using Excel, Python, or Google MLOps. So basically the most important thing is that I'm using Excel for this activity for model creation, because Excel, the entry bar for Excel is low. So there are like I'm not very proficient with Python. That's why I'm sticking to some Excel as a tool to create my model. The next thing, important thing is that I'm dividing my model into three different things, two different portions. One is for training data, other is for the uh, validation data. So for the training data, I'm again dividing it into five parts to make sure I can do the cross verification so that I can run these five chunks of data separately for the data training. And ultimately, so basically I want to avoid the overfitting problem of the data. And then in terms of validation of the data for this, so basically the algorithm, well, algorithm issues. So basically there are three important things. So for the algorithms, I will be choosing based on the uh, 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 about the accuracy, how much accuracy you need. The second thing is that how much computational latency I'm looking into this data. And the third thing is that the most important is basically interoperability, that how visible how much visibility I have that some decision is made. So in this case, I believe that I need more visible uh, so visibility, that how decision made. So I will be sticking with the linear regression. So in terms of data verification, so the most important thing is how I'm going to verify. So that since I have decided to do the linear regression model, so I will be verification with the mean absolute error. So mean absolute error, it means that I choose this thing because I wanted to avoid that outlier don't impact my results. So I don't think that outlier values are very important, because there might be couple of values which are outliers. So I don't think that the outliers can help me to identify that they are part of the trend. So if there are outlier values, I can ignore them. So that's why I'm using a mean absolute value error as a as an error technique for the model verification.